This is continuing 9.7. We're up to number 16 we're going to do next. So I'm looking at number 16 and I see this weird square root k squared plus 1. Well, I think, well, all right, that's kind of close to square root of k squared, which would just be k. So then I have our favorite, p series down here, 1 over k squared. So I have this plus 1 here. So I need to think, is this are these terms less than the convergent p-series or more than the convergent p-series? Because if they're less, then I can just use a straight comparison test. If they're more, then I have to use the limit comparison test. And I think they're less. So let's just lay out an inequality and see how I can get that. So 1 over k, square root k squared plus 1, that would be less than 1 over k square root k squared. It's less because I'm adding into the denominator, and we can just that's considered justified when we say that. So we know that that's true. So this equals 1 over k. It's really the square root of k squared is really absolute value of k, but since k is a positive number, it doesn't matter. So this is 1 over k squared. So now I have my problem series is less than a known convergent series. That's a perfect setup for regular comparison test. So I've already written the inequality, so I have to say sum from k equals 1 to infinity of 1 over k squared. I have to give a reason why that converges. Converges because, it doesn't matter how many times you've said this, you have to say it on the AP exam, okay? Because it is a p series with p greater than 1. All right, and then we've already got this inequality, so now we can say the sum from k equals 1 to infinity of 1 over k square root k squared plus 1 converges by the comparison test. Our full justification requires the inequality, the comparison series and the reason why it converges, and our own series and the citation of the test. So that's number 16. All right, so number 19, just jumping around here, some problems. Number 19 is we have sum k equals 1 to infinity of 2 to the k minus 1, 3 to the k plus 1 over k to the k. So as I think about strategies, it looks pretty weird. It doesn't really seem like it compares to anything obvious. I might be able to do something like pull out a 9 so that these exponents match, but I don't know if that's really helpful. I think that what I'm looking at here is if I did k plus 1 and all these things and then flipped it over and multiplied, I think a lot of things would cancel. So I'm going to try, just as a strategy here, using ratio test. So in order to do that, I can separately look at what is a sub k over a sub k plus 1. I'm going to leave off the absolute value and the limit for now, so I can just compute what that is. So putting in, oh, that's backwards. It's a sub k plus 1 over a sub k. So when I put in the k plus 1, this one's going to become 2 to the k. So I'm going to have 2 to the k. This one's going to be 3 to the k plus 2. This one's going to be k to the k plus 1. And then when I multiply by 1 over a sub k, so I'm going to flip this over. So I'm going to have k to the k in the top. And the bottom, I'm going to have 2 to the, we just leave all these alone. K minus 1, 3 to the k plus 1. Okay? Is that okay? Que pasa? K to the k. So now we just got to look at that and say, all right, what simplifies? Because I suspected some things were going to simplify. Well, I've got one more k in the top than in the bottom. I've got one more 3 in the top than in the bottom. So I'm going to have 6 out of just reducing all these terms right here. This one, I've got one more k in the bottom than I do in the top. So I have 6 over k. So I like that because the limit of that is going to be 0. So now I can say, what is the limit as k approaches infinity of the absolute value of a sub k plus 1 over a sub k? It's equal to the limit as k approaches infinity of the absolute value of 6 over k, and that equals 0. So I worked this out as scratch work, and it's fine. I can use it, but it's important that my final statement starts with this limit of the absolute value. And once I say the limit of the absolute value of the ratio of the terms is 0, then I can say sum from k equals 1 to infinity of 2 to the k minus 1, 3 to the k plus 1 over k to the k converges by the ratio test. And of course, ratio test really tells me that it converges absolutely. So I could say converges absolutely and therefore converges. But the reason I'm skipping that is that all these terms are positive. There's nothing negative there. So the absolute value is meaningless. So that's number 19.